Yeah, welcome to our first tutorial session from Smart Edge. This will be our automotive use cases. So there will be two talks, and the first one is from Duong from Bosch and Louis from Fraunhofer. So please welcome Louis and Duong. The stage is yours.
So today we are going to do a tutorial on virtual environment and traffic scene graph. Firstly, I'd like to recall briefly what had been mentioned yesterday about the scene understanding. After the stage on object detection, we need to do two things to obtain the scene graph. The first is the motion detection, and the second is perspective transformation. So for the motion detection, we need to match the same object between recent frame. So here we are seeing the same car in 5 recent frame, and by matching the bounding boxes, we can detect the motion track and the motion vector. And for the second thing to do is the perspective transformation. We need to estimate the top-down view of the whole scene. From this top-down view, we can estimate the vehicle position and the vehicle moving type. So that was yesterday, and today we are going to do some experiment on the edge device, which is NVIDIA Jetson Nanos with 128 core CPUs, quad-core ARM CPUs, 4 GB memory, and 16 GB storage. And now I'm going to walk you through all the setup and the demonstration. So here for the object detection, we're gonna use YOLO version 9. So to set up YOLO, we need to install the package. Then we need to download the checkpoint YOLO v9c and place the file somewhere on the local machine. Then we detect the object for a video frame using a few lines code here. So the first thing we need to initialize the model, then we do the prediction. And here the prediction will contain all the bounding boxes for all the objects. Next step is the motion detection. So we need to consider at least 2 frames. The first frame is the current frame F1 and the fifth to last frame F5. So for each object in F1, we look for the most similar object within the set of objects from F5. And here the similarity is calculated by the bounding box location and the pixel color within the bounding box. And it's up to you to decide whether the bounding box location or the color is more important. And then the motion vector is the vector between the center point of the two bounding boxes. And before moving to the next step, I'd like to show you a short demo video of the motion detection. Okay. So here you see that when a vehicle starts moving, then we can immediately see the motion track and the motion vector. Yeah. The second thing we need to do is a perspective transformation. So we do that by first manually selecting any 4 point. So we just select any 4 point that works. And then we use any image editor to transform the point so that the original views will look like a top-down view. Then we got 2 set of points, short point and destination point. Then we can obtain the projection matrix using OpenCV tool. So here the big M here is the projection matrix. And finally, we transform all the bounding boxes and motion vector by transforming the point. So here's how we transform a single point. So a single bounding box has 4 points and a vector has 2 points. Then we can compute the angle between two objects. And for estimating the distance between two objects, we need to define a scaling factor. So basically, how many pixels in the image to be considered 1 meter in real life. And finally, don't forget how we define the possible orientation, the distance, and the moving type, depending on the angle between the moving direction of the two objects. Finally, I'd like to show you another demo video for the scene understanding. Yes. As you can see that we have pair connection between each pair of the objects. So here we see that this car and this car. So this car is in the west side of this one, and the distance is about 6.8 meters. And for Jetson Nano, we could already achieve about 10 frames per second speed. And we have tried many models, and none of them could achieve such results. Okay, after we have done with the scene understanding, then there are many applications. And today, our partner from Fraunhofer will take the scene graph to generate new data for use case 1.